All right, guys, we'll go ahead and get started with these notes here. So as I mentioned in class, in general, I'm not going to be posting notes while we're in the hybrid setting, or at least you guys won't need to watch these. But I do want to make these for those of you who are at home, if it's for COVID reasons or something like that, or if you just need something to look back at and look at a few examples here. So I'm going to go ahead and start working on these here. If this is the first time you're doing notes for this chapter, make sure you label a new chapter in your notebook. So this is going to be Unit 5. And specifically with Unit 5, we are talking about triangle properties. So what are these pieces of information that we know about triangles? That's what we're going to kind of talk about throughout this whole unit. Okay, so triangle properties, and then 5.1 types of triangles is what we're talking about today. Okay, you can add the date that we took this as well, and our objective is to be able to identify triangles in two ways, one by its side lengths and then the other by its angles. And then we're also going to use that information to solve for different problems here. So the ways that we can name triangles here, the first type is we can name it by its angles. Okay, so I want you to write this with me here. An acute triangle. An acute triangle is just a triangle with all acute angles. Okay, simply put, an acute triangle is just a triangle with all acute angles. So if I want an example of this here, remember acute means it's an angle measure that's less than 90 degrees. So let's say, for instance, this could be 70 here. Let's go with, let's say 50, and then we'll go 60 here. Okay, just keeping it simple. If I look at a triangle and I know all the angle measures, or at least know two of them because I can always find the third, if I see all acute angles in there, then that is going to be an acute triangle. All right, simple enough. All right, next one here, a right triangle. A right triangle we'll see a good amount in this class and work through problems with that. A right triangle is just a triangle with one right angle. Triangle with one right angle. Okay, so notice we could still have acute angles in it, but as long as I see one right angle, or in other words, like we talked about, a 90-degree angle, and that's all I would need to say that this is a right triangle. So I can just draw this here. Remember, a right angle is just two perpendicular lines. So intersects at 90 degrees, and we draw that little box to denote that. And then again, it doesn't really matter what the other two are here. This could be 30 and 60, it could be 45 and 45, it could be any two numbers really, as long as they add up to the remaining 90. And notice we only need one of them, and we actually can't have two of them because we know all three angles in a triangle should add up to 180. So I can't have two angles that are both 90 degrees. All right, next one here, an obtuse triangle. Obtuse triangle, kind of going along with the same theme as the others. An obtuse triangle is just a triangle with one obtuse angle. Okay, a triangle with one obtuse angle. So same as before, if I'm creating a picture for this, all I need is one of them and in fact I can only have one of them. So let's just create this here. And remember, obtuse, as a reminder, just means it's more than 90 degrees, but it's just less than 180. So for instance, if we made this angle, let's call it 110 degrees, it doesn't really matter as long as it's over 90. Okay, if I saw this, it doesn't matter what the other two add up to. This could be 35 and 35. Okay, again, doesn't really matter as long as I see one of them, and that is going to be an obtuse triangle. And same thing as what we saw last time, I can't actually have two obtuse angles, because that would mean both of them are over 90, and I know all three angles add up to 180. Okay, and then last one here, equiangular triangle. Equiangular triangle is a triangle, kind of like the name suggests, or like it sounds, triangle with all three equal angles. Okay, all three of the angles in that picture, or in that triangle, are going to be equal. Okay, so again, I'll write an example here. We want all the angles to be the same. So I'll draw a triangle that looks like this. And then one other thing as well is we know all the angles have to add up to 180. So if all the angles add up to 180 here, and there's three of them, then that means each one If I divide 180 by 3, that means each one has to be 60 degrees. Okay, this is the only example of an equiangular triangle you'll ever see, is all of them have to be 60. They'll never be 50, they'll never all be 70. Only way to create it is all being 60 so that they add up to 180. Okay, so again, we can look for these different patterns and be able to just name these different triangles and identify them. And that's what we're going to practice here. So, for example 1, we'll look at this here. We have this diagram. You can take a second and if you'd like and pause your video. And sorry, I forgot to mention at the beginning, I will try to put my face on these as well later on, because I know it can be a little easier to follow along than just listening to a voice. But for right now, we'll just do this, and I'll try to keep them as quick as possible. Okay, so we have this here triangle, or we have this big figure with actually 3 different triangles in it. And I'm saying, given this diagram, I want to identify each triangle by its angles. So we're just going to look at this piece by piece here. So first one, if I look at this, I have triangle PQS. So if I'm looking at this here, notice I have 45 and 45, and then there's a couple different ways I can figure out the last one. Okay, one way to think about it is the fact that if this is a straight line right here, and one side of it is 90 degrees, because remember that box tells us it's 90 degrees, then that means the other side has to be 90 as well, because I know 2 angles on the same line should add up to 180. So I have this triangle here, I have 45, 45, and 90. So which one of those does it match? Well, remember, we have one right angle, so this is what we're going to call a right triangle. Okay, simply put, one right angle, that is a right triangle. All right, next one here, SQR. So this time we just need to look at those 3 points, S, Q, and R. Now we're looking at the triangle on the right side, and notice we actually run into the same thing. Even though the other 2 angles are different, 59 and 31, there's still a right angle in there. And since there's still a right angle in there, that is still a right triangle. So still a right triangle, only need 1. All right, and then last one here, we're going to talk about the triangle on the outside, triangle PQR. So if I look at this here, PQ and R. Notice one's angle is 45, another angle, and we're looking at the outside, the big one, is 31, and then this last angle, angle Q, is actually what you get when you add up the 2 pieces. So angle Q, I'll just write this to the side, is going to equal these 2 added together, the piece plus the piece. So 45 plus 59. So right here, I get angle Q equals, I could just add these up in my head or in a calculator, but this is going to come out to be 104 degrees. So if I have 3 angles here, 45, 31, and 104, notice here 104 is an obtuse angle, so this would in fact be an obtuse triangle. And that's basically all we're looking for is there a right angle? No. Okay, is there an obtuse angle? No. And if it's not one of those 2, it's most likely just the last one, acute. Okay, and then there's the very rare case where it's equiangular, and we'll be able to see those. Okay, so that's one way we can name triangles, is by their angles. We also have another piece of triangles that play a role into it, and that would be the sides. So there are 3 different ways that we can name our triangles by its sides. All right, so first one is what we call an equilateral triangle. And notice this is different from the other one that we already wrote down. That was equiangular, this one being equilateral. Lateral just meaning the sides. Okay, so an equilateral triangle is just a triangle. And again, you could kind of guess this one, a triangle with 3 congruent sides. Okay, an equilateral triangle is a triangle with 3 congruent sides. So if I wanted to see an example of this here, okay, I could just draw that same kind of triangle that we saw earlier. And in this case, remember, we're not worried about the angles on these ones, we're just worried about the sides. So for instance here, I could say this is 5, 5, and 5. So if I see all 3 sides are congruent or the same, then they're equilateral. All right, next one here. Try to throw this inside to get this out of the way. Okay, an isosceles triangle. An isosceles triangle is just a step down from this. So an isosceles triangle is a triangle with, and we can just say at least 2 congruent sides. So now we're just taking a step down. So instead of having all 3 of them equal to each other, we're just saying at least 2 of them are equal to each other. So again, an example of what this could look like you can see a few different, or there's many different ways to draw an isosceles triangle. But one way you could see here is we could say maybe these two sides are congruent. So let's say maybe 8 and 8. Okay, it doesn't matter the number as long as they're the same. And then the last side just has to be different from the others. So in this case, we'll just say 3. And again, this would be considered an isosceles triangle because I have 2 congruent sides. Okay? And then finally, last one here, a scalene triangle. A scalene triangle is a step down from the previous one. So we said 3 congruent sides, 2 congruent sides. And then really if you're saying one side is congruent, that means really no sides are congruent. So a scalene triangle is a triangle with no congruent sides. Okay, so scalene just means that all 3 sides are different. All right, so a few examples of this, or I guess one example of this. Okay, it could look many different ways. We just need to draw 3 sides that are all different lengths. So let's say this is 4, this is 9, and this is 10. Okay, this would be considered a scalene triangle. And notice you could name a triangle both by its sides and by its angles, but on most of the problems that we're going to work on today, we're really just focused on one, and you'll just have to pay attention to what the instructions say. Okay, but these are 3 ways that we name them by their sides. Either all 3 of them are congruent, at least 2 of them are congruent, or none of them are congruent. All right, so let's practice that here and use that on example 2. So on example 2 here, we're given M is the midpoint of JL, and we want to identify this triangle, or these triangles, I should say, since there's multiple in this picture, by their angle measures. Or I'm sorry, and that's a typo. And that should say side lengths. We actually don't have any angle measures here. So we're going to identify this by its side lengths. So if you'd like to, you can pause your video and sketch this here, but otherwise we'll kind of dive into it. So first triangle I'm looking at is I'm told M is the midpoint of JL, and I want to find what kind of triangle I have with KML. Okay, with KML. So notice here, I have one side that's 1.3, and on the other 2 sides, I don't know their specific measures right now, or I'm not given them, but I am given that they each have a dash mark on them. And remember, that dash mark means that those 2 sides are congruent. So I know at least these 2 are congruent, so now I just want to try to see if I can figure out exactly what they are to make sure they are not the same length as the third one, because that's going to determine our answer here. So if I look at this, remember the given information says M is the midpoint of JL. So right here I'm looking at JL. I see the whole thing is 1.5, which means if M is the midpoint, then each of these segments is going to be half of that. So this segment is going to be 1.5 divided by 2, which if we do that in our calculator is 0.75. And then this side length right here is also going to be 0.75, each of those halves. And again, we get that because M is the midpoint. Okay, and then since we know that we have this dash mark here with line segment ML, that means the other line segment with that dash mark is also going to be 0.75 as well. So that little piece of information kind of gives us the rest of the sides that we need for this. So if I'm looking at triangle KML, what's the answer? Well, we see 0.75, 0.75, and 1.3. So final answer here is going to be isosceles. I have 2 side lengths that are congruent, but not the third. So that would be what we call isosceles, or an isosceles triangle. Okay, next one here, I have triangle JML. And that doesn't make sense, so that must be a typo. So I'm going to change this here to, I think that's supposed to say JKL. Okay, JKL here. So let's look at the big triangle on the outside here. JKL. And notice we're actually given all 3 of these here. We're given 0.75, 1.3, and 1.5. So if I look at all 3 of those line segments, I see that none of them are the same. So this would in fact be a scalene triangle. This is a scalene triangle. All right, and then the last one here, JMK. So now we're looking at this other small triangle that we have here. Okay, JMK, connecting these here. And notice I have all 3 of these side lengths. I have all 3 of them are 0.75. So final answer here would be equilateral. And again, that's different from equiangular for these kinds of problems. So all 3 sides are the same. That is an equilateral triangle. So just notice how we can name different triangles by those. And then we can actually use these if we're given that information to start, then that can help me find some different side lengths and different angle measures here. Okay, so on this one here, I'm given triangle ABC. First thing I want to do is I want to identify the type of triangle that I have, and then I want to solve for x. So if you'd like to, you can pause your video and sketch this here. But if I'm looking at this one, first thing I need to do is identify the type of triangle that I have. Well, I'm not given the actual lengths, but I am told the same thing as before, which is that I have these little two dash marks here, which tells me that those two sides are congruent. Since I have those two sides that are congruent and I don't have a dash mark on this third side here, that means only those two are congruent to each other. So first piece here, what kind of triangle do I have? This is what we call an isosceles triangle. Only two of the side lengths are congruent. And then second question is, it's wanting me to solve for x. So I have three different choices here of things that I could use. I have 4x plus 1, 5x minus 0.5, and 9x minus 1. Okay, and I could try to figure out some way to add these all up or use all of these, but it actually doesn't, we actually don't need to use all three of them. We only really need two of them, because we notice here that we have these two congruent sides, which means these two expressions are going to be equal to each other. So that's all I need to do is I can just say 4x plus 1 equals 5x minus 0.5. And notice the 9x minus 1 doesn't actually play a role here, so I can just cross that out. And we might see that sometimes where we have geometry problems with extra information that we're not going to use. Okay, now that I've got this set up, I just need to solve. So there's multiple steps to do that. I like to work with the variables first. So I'm going to subtract 4x from both sides since it's a positive 4x. When I do that, I'm going to be left with 1 equals 1x, or just x, minus 0.5. And then last step here, add 0.5 to both sides since it's negative. When I do that, these cancel. I'll move x over to the other side. Okay, I'm going to get x equals 1 plus 0.5, so just 1.5. Okay, and then last thing we need to do, we always double check once we find a variable in geometry, do I need to plug that back in? In this case, it just tells us to solve for x, so we are good. Okay, so these are just kind of the problems that we're going to be working on with classifying triangles and be able to use this information that we know about the side lengths, all right? So homework assignment for today is 5.1, classifying triangles. And if you were in class, I should have handed that to you. And if you are watching this at home, then it should be posted on the class website as well. Okay, but otherwise, just working on that assignment. As always, if you guys have any questions with any of this, feel free to let me know. Thanks, guys.